In 1977, NASA launched two spacecraft with no destination. They weren't going anywhere specific. They were just going to keep going, past the planets, past everything we had ever explored, past the edge of the solar system, and out into whatever lay beyond. Nobody knew how far they would travel, or how long they would last, or what they would find. They were set off with a golden record bolted to each side, a collection of music, sounds, and images from Earth. A message in a bottle thrown into an ocean so vast that the odds of anyone ever finding it were essentially zero. That was 47 years ago, and those two spacecraft are still alive, still moving, still sending signals home from a distance so enormous it takes light itself 22 hours to make the trip. What they found on the way, and what they have discovered at the very edge of our solar system, is stranger, more violent, and more beautiful than anyone imagined. This is the story of Voyager 1 and Voyager 2, the two loneliest machines in history, and what they saw at the end of the world. To understand what the Voyagers found, you have to understand where they went. In 1977, the outer solar system was almost entirely unknown. We had never visited Jupiter up close, never seen Uranus or Neptune except as faint smudges through telescopes. The Voyagers were built to change that, and they got an almost miraculous opportunity. A rare alignment of the outer planets that happens only once every 176 years. NASA called it the Grand Tour. They had a single window to launch, and they took it. Voyager 2 went first, on August 20th, 1977. Voyager 1 followed on September 5th, but on a faster, more direct path, so it would actually arrive at Jupiter first, despite leaving second. From the moment of launch, both probes were on a journey that would last their entire operational lives. The engineers who built them knew they might function for 5 years. They have now been running for 47. What the Voyagers sent back in those first years was revelatory. At Jupiter, they discovered active volcanoes on the moon Io, the first time anyone had seen active volcanoes beyond Earth, erupting plumes of sulfur hundreds of kilometers into space. They found that Europa, Jupiter's ice-covered moon, had a surface so young and smooth that it almost certainly covered a liquid water ocean beneath, an ocean that might, just possibly, harbor life. At Saturn, they revealed that the rings were not solid bands, but countless billions of individual chunks of ice and rock, sculpted by the gravity of shepherd moons into patterns of extraordinary complexity. Voyager 1 flew close to Saturn's moon Titan, finding it wrapped in a thick orange atmosphere of nitrogen, the only moon in the solar system with a dense atmosphere. This flyby deflected Voyager 1 out of the plane of the solar system entirely, sending it on a path that no spacecraft had ever taken, directly upward and outward, away from everything, into the dark. Voyager 2 continued on to Uranus, where it found a planet knocked on its side, its axis tilted so far that it rolls around the sun like a ball rather than spinning like a top. And then on to Neptune, the outermost planet, where it discovered winds of over 2,000 kilometers per hour, the fastest winds in the solar system, and a moon called Triton orbiting backwards, which meant it could not have formed there. It was a captured object, a wanderer from another part of the solar system, pulled into orbit and slowly spiraling inward to its eventual destruction. After Neptune, there were no more planets. There was only the dark. But the Voyagers kept going. Their nuclear power generators, running on the slow radioactive decay of plutonium, continued to produce electricity, and their mission was quietly redefined. Instead of exploring planets, they would explore the edge, the vast, almost empty territory where the sun's influence fades and the galaxy begins. And to understand what they found there, you have to understand something about the bubble we live in. The sun doesn't just sit there emitting light. It constantly breathes out a stream of charged particles, electrons, and protons, moving at up to 1,000,000 kilometers per hour in every direction. This stream is called the solar wind, and it blows outward continuously, past Mercury, past Venus, past Earth, past Mars, and Jupiter, and Saturn, and the ice giants, far past the orbit of Pluto, out into the void. Everywhere the solar wind reaches, it creates a bubble, a protective envelope of the sun's influence called the heliosphere. Everything inside that bubble is, in a meaningful sense, still part of our solar system. Beyond it lies something else entirely: interstellar space, the space between stars, filled with matter and magnetic fields left behind by other stars, ancient and alien. The edge of the heliosphere, the point where the solar wind finally gives out, is called the heliopause, and reaching it was the ultimate prize. But getting there turned out to be far stranger than anyone expected. The first shock came at the termination shock, a region several billion kilometers before the heliopause, where the solar wind abruptly slows as it pushes against the pressure of interstellar space. Think of it like a jet of water hitting a flat surface, fast until impact, then suddenly spreading and slowing. The Voyagers found that when the solar wind hit this boundary, it became denser, hotter, and more turbulent in ways the models hadn't predicted. The churning region beyond, called the heliosheath, was a confused zone where particles from inside the heliosphere mixed with the first hints of what lay outside. Voyager 1 crossed the termination shock around 2004, Voyager 2 in 2007, but at different points. What both measured wasn't the same. The termination shock turned out to be asymmetrical, pushed in on one side by the interstellar medium pressing harder from that direction. And then came the wall of fire. As the Voyagers approached the heliopause, their instruments detected something nobody had anticipated. The temperature spiked, not a little, enormously. The plasma in the boundary zone was at somewhere between 30,000 and 50,000 Kelvin, far hotter than the surface of the sun. Here at the edge of our solar system, in the region where the sun's influence was dying, there was a raging thermal barrier, a seething zone of superheated plasma where the solar wind and interstellar matter were slamming into each other. Scientists have since confirmed this discovery and published it. It's real. The edge of our solar system is not a quiet fade to black. It is a violent collision zone, a place of enormous energy, where two cosmic winds are fighting for dominance. Nobody had predicted it. Nobody had modeled it. The Voyagers found it simply by going there. Voyager 1 crossed the heliopause on the 25th of August, 2012. The signals from its instruments showed a sudden drop in solar particles and a sharp rise in high-energy particles from outside, cosmic rays, the radiation left by distant stellar explosions and other violent events across the galaxy. These cosmic rays had been trying to get in for billions of years, and the heliosphere had been partially blocking them. Voyager 1 was now on the other side of that shield, in true interstellar space, the first human-made object in history to leave the solar system. Voyager 2 followed on the 5th of November, 2018, crossing at a different point and measuring slightly different conditions, which told scientists that the heliopause was not a uniform boundary. It was dynamic, rippling, changing, more like a coastline being buffeted by waves than a clean edge on a map. Research published in 2024 suggested it might not even be a sharp boundary at all, but a thick layer, a broad zone of interaction where the two magnetic environments blend and tangle. What the Voyagers detected beyond the heliopause was its own revelation. In late 2020, Voyager 1 picked up something extraordinary. Its plasma wave instrument detected a persistent, steady hum, a vibration in the interstellar plasma, continuing in the quiet beyond the heliopause. Scientists described it as hearing interstellar space for the first time. It wasn't dramatic, it was quiet, sustained, and strange. A whisper from the void, the sound of the space between stars. Meanwhile, the magnetic field readings in interstellar space turned out to be deeply puzzling. Before the crossing, scientists expected that the direction of the magnetic field would sharply change at the heliopause, since inside the heliosphere, the sun's magnetic field dominates, and outside, the galaxy's interstellar field should take over. But it didn't, or at least not in the way expected. The magnetic field just beyond the heliopause aligned in ways that nobody had predicted, suggesting that the solar bubble may be pressing on and distorting the interstellar field, or that the two fields are tangling and reconnecting at the boundary in complex ways that our models had not imagined. The edge of the solar system was not a clean threshold between our world and the galaxy. It was a zone of mixing, interaction, and surprise. And the cosmic ray data changed everything. Inside the heliosphere, the sun's magnetic field deflects many of the high-energy particles raining in from the galaxy. Beyond the heliopause, cosmic ray intensity jumped dramatically. For any future astronauts who might one day travel this far, this isn't a curiosity, it's a survival issue. The radiation outside the heliosphere is far more hostile than inside it, and the Voyagers have given us the first real measurements of what that actually means. But even as the science kept coming, the machines were dying. The Voyagers were built in the 1970s with technology from that era. Their computers have less processing power than a cheap digital watch today. They run on electricity from plutonium generators that lose about 4 watts of power every year. By the mid-2020s, the power situation had become critical. One by one, the instruments had to be switched off. Voyager 2 shut down its plasma science instrument in 2024 to save power. In early 2025, NASA shut down more instruments on both probes, trying to eke out enough electricity to keep even the most essential systems running. Then came the budget crisis. In 2025, NASA faced a 26% funding cut to the Voyager program, raising the nightmare scenario that the most distant spacecraft in history might be turned off not because it failed, but because someone decided it cost too much to listen to. But the most extraordinary chapter in recent Voyager history was a software crisis that unfolded across the depths of interstellar space. In November 2023, Voyager 1 stopped sending coherent data. Instead of its usual stream of scientific and engineering information, it began transmitting a repeating, meaningless pattern of ones and zeros, gibberish, from 15 billion miles away. For months, engineers at NASA's Jet Propulsion Laboratory worked to diagnose the problem. The round-trip communication time, the time for a signal to travel from Earth to Voyager 1 and back, was 45 hours. Every attempted fix required waiting nearly 2 days to see if it had worked. After months of investigation, the engineers located the problem. Roughly 3% of the memory on the flight data subsystem, the computer that packages and transmits scientific data, had been corrupted. A single chip had failed. On a spacecraft 15 billion miles from Earth, launched in 1977, running on less power than a refrigerator light bulb, the engineers devised a workaround. They rewrote the flight data subsystem's code remotely, redistributing the functions that had been stored on the corrupted memory chip across other parts of the computer's memory. Like a surgeon performing a delicate operation on a patient they could only reach by radio, with a 45-hour delay between every move. And it worked. By June 2024, Voyager 1 was sending coherent data again from all 4 of its remaining active instruments. The team had reprogrammed a 47-year-old computer from 24 billion kilometers away, one careful command at a time. It is, without exaggeration, one of the most remarkable feats of remote engineering in history. And through all of this, the 2 probes carry their golden records. On each spacecraft, bolted to the side, is a 12-inch gold-plated copper disc, encoded with sounds and images from Earth. The sounds of surf and wind and thunder. The songs of whales and birds. Music from Johann Sebastian Bach and Chuck Berry, and a Peruvian wedding song. Greetings in 55 languages, from a Sumerian spoken by nobody alive today to an ancient Chinese dialect. The sound of a mother kissing her child. A mathematical diagram of where Earth is in the galaxy, in case whatever finds the record needs directions. The golden record was never really meant for aliens. The odds of it being found are essentially 0. It was a message about who we were at the moment we first reached beyond our solar system. A gesture of hope and curiosity thrown into an infinite dark. Right now, 2 of them are drifting through interstellar space at roughly 17 kilometers per second, carrying a mother's kiss into the void between the stars. So, here is where things stand. Voyager 1 is currently about 24 billion kilometers from Earth, roughly 160 times the distance between Earth and the Sun. Voyager 2 is somewhat closer, around 20 billion kilometers out. Both are in interstellar space, still transmitting, still measuring the environment around them, still calling home across a distance that makes the mind go blank. Scientists estimate that Voyager 1 has perhaps 5 to 10 years of operational life remaining before its power generators fall below the threshold needed to run any instruments at all. After that, it will fall silent, but it will keep moving. In 40,000 years, it will pass within about 1.6 light-years of a star in the constellation Camelopardalis. In the far, far future, long after the Earth is gone, Voyager 1 will still be out there, drifting, carrying its golden record through the dark. It will outlast us. It will outlast our planet. It will outlast our sun. What did Voyager see at the edge of the solar system? It saw a wall of fire 50,000 degrees hot. It heard the hum of interstellar space. It measured magnetic fields that bent the rules of what we thought we knew. It showed us that the edge of our world is not a boundary, but a battlefield, a dynamic collision of cosmic forces that has been raging in the dark for billions of years. And it showed us something else, that a machine built by human hands in 1977, with the computing power of a pocket calculator, launched into the void on a voyage with no destination, could survive for nearly half a century and send back the first direct measurements of interstellar space. We built something that went where nothing from Earth has ever gone, and it is still going. If a story like this astonished you, hit that like button and subscribe, because we are only just beginning to uncover the impossible places our universe has been hiding from us. We'll see you in the next one.